Hello guys, welcome to another video here on NiceSec. We're treating the pre-security part, learning part here on Tryhackme, and today we're treating OSI model. Without further ado, let's jump right into it. Now, the OSI model here, we're going to learn about the fundamental networking framework that determines the various stages in which data is handled across network. All right. Okay. Now, let's begin. Task one. What is the OSI model? So what exactly are we treating today? Now, the OSI model, or what we call the Open Systems Interconnection Model. Open System Interconnection Model is an obsolete fundamental model used in networking. All right. This critical model provides a framework dictating how all networked devices will send, receive, and interpret data. Now, one of the main benefits of the OSI model is that devices can have different functions and designs on a network while communicating with other networks. While communicating with other devices. All right. Now, data sent across a network that follows the uniformity of the OSI model can be understood by other devices. All right. Now, the OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer that data travels through, specific processes take place, and the pieces of information are added to this data, which is what we will come to discuss in the upcoming tasks within this room. Now, however, for now, we only need to understand that this process is called encapsulation, which is what the process in which pieces of data are added to this, pieces of information are added to this data, which is being sent. Now, the process is called encapsulation, and what the OSI model looks like is in the diagram below. So we have the application layer, the presentation layer, session layer. The fourth layer is the transport layer, third layer network, data link, and physical. All right. What does the OSI in the OSI model stand for? Open systems. It's an open systems interconnection model. Okay, I think you just asked what the OSI means. All right. Now, how many layers in digits does the OSI model have? 7 layers. What is the key term for when pieces of information get added to data? Encapsulation. Encapsulation. Okay. All right. Now, let's go into task 2, layer 7, the application. Now, the application layer of the OSI model is the layer that you will be most familiar with. The familiarity is because the application layer is the layer in which protocols and rules are in place to determine how the user should interact with data sent or received. Now, everyday applications such as email clients, browsers, or file server browsing software such as FileZilla provided a friendly graphical user interface GUI for users to interact with data sent or received. Okay, so the application layer is what determines how the user communicates with the data that is being sent or received. Now, other protocols include DNS, which is the domain names system, which is how website addresses are translated into IP address. Okay. Now, let's get to it. So this is what like user, application layer looks like, which is basically more like a graphical user interface kind of thing. Okay. Now, what is the name of this layer? Application. And what is the technical term that is given to the name of the software that users interact with? That should be graphical user interface. Oh, did I get an interface? Okay. Now let's move on to the task tree. Over here in task tree, layer 6, which is a presentation. Now, layer 6 of the OSI model is the layer in which standardization sorry about that, starts to take place. Okay, because software developers can develop any software such as an email client differently, the data still needs to be handled in the same way, no matter how the software works. Now, this layer acts as a translator for data to and from the application layer, which is layer 7. Now, the receiving computer will also understand data sent to a computer in one format, destined for in another format. For example, when you send an email, the other user may have another email client to use, but the contents of the email will still need to display the same. So, security features such as data encryption like HTTPS when visiting a secure site, of course, occurs at this layer. Okay. Now, what is the name of this layer? It's a presentation. And what is the main purpose of this layer? What is the main purpose that this layer acts as? Translator. Translates anyhow kind of data so that it's generalized, something like that. Okay. Now, task 4, layer 5, session layer. Okay. Once data has been correctly translated or formatted from the presentation layer, which is layer 6, the session layer, layer 5, will begin to create a connection to the other computer that the data is destined for. Now, when a connection is established, a session is created. Now, so when a connection is established, a session is created. Okay, noted. Whilst this connection is active, so is the session. Now, the session layer, layer 5, synchronizes the two computers to ensure that they are on the same page before data is sent and received. Okay, so we have to create a connection with whoever, the two systems or devices. Once these checks are in place, the session layer will begin to divide up the data sent into smaller chunks of data and begin to send these chunks. These chunks of data is called packets. One at a time, and then this dividing up is beneficial because if the connection is lost, only the chunks that weren't yet sent will have to be sent again. All right, not the entire piece of the data. Think of it as loading a saved file in a video game. Okay, yeah, it's saved like in chunks, like it start loading step by step or chunks by chunks. Okay. Now, what is worthy of noting is that sessions are unique, meaning that data cannot travel over different sessions, but in fact only across each session instead. Okay. Now, what is the name of this session? For this layer? Session, of course. Now, what is the technical term for when a connection is successfully established? That should be session as well. So, if a connection is established, we'll call that a session. What is the technical term for small chunks of data? That should be packets. All right, great. We are done with task 4. Task 5, layer 4, which is transport. All right, Now, layer 4 of the OSI model plays a vital part in transmitting data across a network and can be a little bit difficult to grasp. Now, when data is sent between devices, it follows one of two different protocols that are decided based upon several factors. Now, it's either through TCP or UDP. Now, let's begin with the TCP. The TCP means the Transmission Control Protocol, potentially hinted by the name. This protocol is designed with reliability and guarantee in mind. So, this protocol reserves a constant connection between the two devices for the amount of time it takes for the data to be sent and received. Now, not only this, but the TCP incorporates error checking into its design. Now, error checking is how TCP can guarantee that data sent from the small chunks in the session layer, which is layer 5, has been received and reassembled in the same order. That makes sense. Now, let's summarize the advantages and disadvantages of TCP in the table below. Now, advantages of TCP, disadvantages of TCP. Now, the first advantage is it guarantees the accuracy of data. While the disadvantage in this case is that it requires a reliable connection between the two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. Wow. Okay. Now, capable of synchronizing, one of the second advantage is capable of synchronizing two devices to prevent each other from being flooded with data. All right. Now, the disadvantage is that a slow connection can bottleneck another device, as the connection will be reserved on the receiving computer the whole time. Okay. And the last advantage here is performs a lot more processes for reliability. All right. Now, the disadvantage, the last disadvantage is the TCP is significantly slower than UDP because more work has to be done by the device using this protocol. All right. Now, in summary, TCP is used for situations such as file sharing, internet browsing, or sending an email. The usage is because these services require the data to be accurate and complete. No good having half a file, of course. Now, in the diagram below, we can see how a picture of a cat is broken down into smaller pieces of data known as packets from the web server, where the computer reconstructs the picture of the cat into the correct order. And the web server sends this cat and it breaks it down, through packets. And then this is the final one by the computer. All right, so if there's anything and then only packet 2 gets here, it will not make any sense. Okay. I see the importance of TCP here. Now let's move on to the user datagram protocol, or the user datagram protocol, or UDP for short. Okay. Now the protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer, whether it gets there or not. There is no synchronization between the two devices or guarantee. Just hope for the best and fingers crossed. Okay. Now, while these sound disadvantageous, it does have its merit, which we will lay out in the table below, and advantages of UDP and disadvantages. Now, the first advantage of UDP is that it's much faster than TCP. Right, there's no much things needed for the computer or the devices to perform, so it's faster. UDP doesn't care if the data is received. That's the first disadvantage. All right, now UDP leaves the application layer, which is the user interface, to decide if there's any control over how quickly packets are sent. Now that's an advantage. Yeah. Now, the disadvantage is it's quite flexible to software developers in this sense. That's the disadvantage of UDP. It's flexible to software developers. Okay. Now, the last advantage here for UDP is that UDP does not reserve a continuous connection on a device as TCP does. It doesn't reserve any connection because maybe there's a sending still going on. Now, this means that unstable connection results in a terrible experience from the user while using UDP. That's what the last disadvantage. Now, using the same example as before, we can now see that only packets 1 and 3 has been received by the computer, meaning that half of the image is missing. Wow, okay. Now, UDP is useful in situations where there are small pieces of data being sent. For example, protocols used for discovering devices, ARP and DHCP, that we discussed in room 2. Yes, ARP and DHCP. Okay, or larger files such as video streaming, where it's okay if some part of the video is pixelated. Pixels are just lost pieces of data. Oh, that makes sense. What's the name of this layer? The name of this layer is transport. Okay, transport. For some reason, ARP, that's address resolution protocol. TCP is I've forgotten. Yeah. What does TCP stand for? Transmission. One thing here in this field is there's lots of Acronyms: Transmission Control Protocol. Protocol. Now, what's the UDP stand for? User Datagram Protocol. Now, what protocol guarantees the accuracy of a data? PCP, of course. What protocol doesn't care if data is received or not? Of course, that's UDP. What protocols would an application such as an email client use? TCP, because we want a complete email, an accurate one. What protocol would an application that downloads files use? We don't want half a file, we want complete. TCP. What protocol would an application that streams video for speed? We need the UDP for that, and we don't care if it's a little bit pixelated. UDP. Great. I love this particular task. Okay, transport layer. Now, task 6, layer 3, network. Now, the third layer of the OSI model, which is the network layer, is where the magic of routing and reassembling of data takes place. Routing means this is where it starts being sent out or start, breaking those, messages into chunks. And then this is also where it's reassembled in the second device where it's being received. Now, routing and reassembly of the data takes place from these small chunks to large chunks. All right. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent. All right. Now, while some protocols at this layer determines exactly what is the optimal path that the data should take to reach a device, we should only know about their existence at this stage of the networking model. Now, briefly, these protocols include OSPF, Open Shortest Path First, and then RIP, Routing Information Protocol. The factors that decide what route is taken is decided by the following. 1. What path is the shortest? That is, how has the least amount of devices that the packet needs to travel across. What path is the most reliable? That is, have packets been lost on the path before? Now, what path, the last one is, what path has the fastest physical connection? That is one path using a copper connection slower or a fiber considerably faster? All right. Now, at this layer, everything is dealt with via IP addresses such as 192.168.1.100. Devices such as routers capable of delivering packets using IP address are known as layer 3 devices because they are capable of working at the third layer of the OSI model. Correct. Computer A, computer B. Remember routers? This is what they do. Yeah. This is the network layer. So what's the name of this layer? Network layer. Will packets take the most optimal routes across a network? Of course, yes. What does the acronym OSPF? Open shortest. Is it open and is it the shortest path? Open shortest path. Let me check what that is again. Open shortest path first. Okay. Open shortest path first. All right, and then okay, I didn't get that. Open. I didn't spell that correct. Open. All right. What does the acronym RIP stand for? Not rest in peace, but RIP is skip my head for Routing Information Protocol. Okay. Routing Information Protocol. All right. What type of addresses are dealt with at this layer? We're talking about IP addresses. All right. We're done with layer task 6, which is layer 3. We are now in task 7, layer 2, data link. Now, the data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds it to the physical connection, which is MAC. So it adds in the physical MAC, which is the media access control address of the receiving endpoint. Inside every network enabled computer is a network interface card, NIC, which comes with a unique MAC address, the media access control address, to identify it. Now, a MAC address or MAC addresses are set by the manufacturer, just like we saw in the last video, I think, and literally burnt into the card. They can't be changed. They are not permeable. Although they can be spoofed when information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it is also the job of the data link layer to present the data in a format suitable for transmission. And what is the name of this layer? Data link. And what is the name of the piece of hardware that all network devices come with? MAC, which is the media access control. Yes, media access control. No, sorry, what is the name of the piece of hardware that all network device comes with? Okay, the NIC, the network interface. It's a hardware, sorry, so that's why. Network interface card. All right, and then let's move on to the last layer, which is task 8, which is layer 1, physical. Now, this layer is one of the easiest layer to grasp, but put simple, this layer references the physical component of the hardware used in networking and is the lowest layer that you will find. Devices use electrical signal to transfer data between each other in a binary number system, which is in ones or zeros. For example, Ethernet cables connecting devices, such as the picture below. So this is how Ethernet cables look like. Okay, they are using transmitting data using electrical signals in binary number systems. Okay, now what is the name of this layer? Last layer, physical. And what is the name of the number system that is both zeros and ones, binary? What is the name of the cables that are used to connect devices? Ethernet. Sorry, I'm not sure I get that. There's no R here, I guess. Ethernet cables. Cables. Yeah. Okay, that's that for the end of the layers. And then let's go on to task 9. There's a practical OSI game. Let's see. Hope I don't get this. Okay, great. Now, can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and review the flag. Can you beat our staff high score of 19 seconds? How fast can I go? Now, click the view site button on the right to start. Already did. Now answer the questions below. Escape the dungeon to retrieve the flag. What is the flag? Okay, are we ready? Now let's play this game. Play. All right, let's go. Okay, let's go. Okay, this looks good. Let's go. Network. How many seconds is that? Okay, transport and session and presentation and application. Oh my god, yo. How many seconds? 28.18 seconds. That is not close. That was close. Less than 10 seconds. Alright, well done. You escaped the dungeon, completed in 28.18 seconds. Let's copy the flag. Yes, Tryhackme OSI dungeon escaped and completed. Let's move over to the last task here is to continue your learning path which is packets and frames. Okay, continue the learning part by joining the packet and frame. We're going to complete that, and then I'll see you guys in the next video for packets and frames. Thank you for watching. Thank you for learning with me, and then I'll see you guys next time. Ciao.